February 14, 2025, a powerful magnitude 6.0 earthquake struck within the Ethiopian rift, marking the most significant seismic event in an escalating sequence of tremors. This latest quake, described by experts as violent, occurred near the Fentale and Dauphin volcanoes in the Afar region, an area already under close observation due to increasing seismic and volcanic activity. Given its intensity and proximity to Addis Ababa, strong shaking was likely felt in the capital, adding to concerns about the broader impact of this event. This earthquake is part of a larger trend of heightened seismicity in the region. Over the past few months, nearly 300 earthquakes have been recorded in the Rift Valley, with the most intense activity beginning in late December. Before this event, the strongest recorded tremor was a magnitude 5.7 in January, signaling a clear escalation. The East African Rift System, where the quake occurred, is an active continental rift where tectonic forces are slowly pulling the land apart. Over millions of years, this process will lead to the formation of a new ocean and the eventual separation of the Ethiopian tectonic plate from the African continent. Seismologists warn that this earthquake may not be purely tectonic, but could have volcanic influences. Reports indicate that magma movement beneath the region has been increasing, with signs of intensifying volcanic activity, including fumaroles, phreatic explosions, and ground fissures. Satellite imagery has also captured unusual cloud formations over the Fentale volcano, raising suspicions of increased degassing. The quake struck at a shallow depth of 10 kilometers, 6.2 miles, with its epicenter just 6.6 kilometers, 4.1 miles, north-northeast of Metahara, a town of over 23,000 people. Initial estimates suggest that around 50,000 people experienced very strong shaking, while another 40,000 felt strong tremors, and nearly 150,000 reported moderate shaking. Beyond its geological implications, the earthquake has raised serious concerns about infrastructure stability in the region. The affected area includes vital transport routes, such as Ethiopia's main highway connecting Addis Ababa to its key port, as well as a crucial railway line. Damage assessments are underway, particularly regarding large-scale projects like the Grand Ethiopian Renaissance Dam, which could be vulnerable to seismic activity of this magnitude. Over 100,000 people have already been displaced, with many more still at risk. Emergency response efforts are being mobilized, including international aid to assist those affected. This earthquake is not occurring in isolation. Seismic disturbances have been detected in other parts of the world, notably in the Santorini region, where continuous tremors and unusual subterranean sounds have been reported. Scientists are working urgently to determine whether these events are interconnected and what further risks may lie ahead. With the potential for continued seismic and volcanic activity in Ethiopia and beyond, ongoing monitoring of these dynamic geological processes remains essential. The population in this region resides in structures that are highly susceptible to earthquake damage. While some buildings adhere to safety codes, the majority are constructed from vulnerable materials such as unreinforced rock, timber, and metal, often built without permits or engineering standards. Recent earthquakes have already triggered secondary hazards like landslides, which may have further contributed to structural damage. Given the magnitude of this latest seismic event, more destruction is expected. Experts have classified this ongoing crisis as a seismovolcanic event, comparable to what has been observed in Santorini. Since December 22nd of the previous year, seismic activity has been intensifying in Ethiopia. Although the region sits atop tectonic fault lines, scientists believe these quakes are not tectonic in nature, but are instead driven by magma movement beneath the Fentale volcanic complex, within the main Ethiopian rift. This geological process is actively rifting the continent, similar to what occurs in Iceland, leading to increased volcanic and seismic activity. In response to these escalating threats, the government has been relocating residents from high-risk areas to mitigate potential disasters. The quakes have already damaged homes, health centers, schools, and essential infrastructure, with at least 2 people reported injured. A particularly alarming development is the rapid expansion of fissures and cracks in the ground, which continue to widen and lengthen, raising serious concerns over the stability of critical structures. One of the most pressing fears is the potential impact on Ethiopia's major dams. The CM Sabur Dam, which retains a significant volume of water, has been closely monitored, but structural engineers have also warned that even the Grand Ethiopian Renaissance Dam, holding vastly more water, could be at risk if subjected to seismic activity of magnitude 6.0 or higher. A structural failure in these dams could lead to catastrophic downstream flooding, threatening hundreds of thousands of lives and affecting neighboring countries. It is particularly concerning that some of these dams were engineered to withstand only moderate earthquakes, with designs accommodating magnitudes up to 5.6, far lower than what has now been recorded. Authorities face a difficult situation, as acknowledging this area as a highly active seismic or volcanic zone could have significant economic consequences. The region is a major economic hub, home to key investments such as Ethiopia's vital railway infrastructure. The financial and logistical impact of ongoing seismic events could be severe. Historically, Ethiopia has experienced an average of 41 earthquakes per year above magnitude 4.0, equating to roughly one earthquake every 8 days. However, seismic activity has surged dramatically in 2025. Already this year, 206 earthquakes above magnitude 4.0 have been detected within a 300-kilometer radius of Ethiopia, marking a significant increase. The recent magnitude 6.0 quake is now the strongest recorded in the country in a decade, with the last comparable event being a magnitude 6.5 earthquake that struck in 1906. Data trends suggest an alarming escalation in both frequency and intensity, raising urgent questions about what may come next. Seismic activity in Ethiopia continues to escalate, with a magnitude 6.0 earthquake recently striking the region. The tremors have been persistent, with multiple foreshocks recorded in the 4.4 to 4.8 magnitude range, further weakening the already fragile landscape. The ongoing seismic unrest is intensifying concerns about structural integrity, as continuous shaking makes buildings and infrastructure increasingly vulnerable to collapse. In response to the crisis, international aid efforts have begun, with reports indicating that other countries have contributed approximately $215,000 to assist Ethiopia in providing essential supplies such as food and clean water for displaced communities. However, given the scale of displacement and devastation, concerns are mounting that this support may fall significantly short of the actual needs. For months, geologists and disaster response teams have been closely monitoring the situation, witnessing its steady escalation. While aftershocks are expected in the aftermath of this recent quake, a larger concern looms. Could this seismic activity be a precursor to a volcanic eruption? The Fentale volcanic complex remains under close scrutiny, as experts debate whether the current intrusion of magma is a continuation of past activity or a warning sign of an imminent eruption. The unfolding crisis raises critical questions about the region's stability and the potential for even greater geological upheaval. Now, let's check the latest updates on earthquakes around the world. Seismic activity in Greece is currently being represented by a single earthquake near the Santorini region, positioned northeast of the main swarming zone. However, a closer analysis of seismic data reveals a far more active and dynamic situation unfolding beneath the surface. Over the past week alone, 1,249 tremors have been recorded in the area, indicating an unusual level of unrest. Examining data from the Raspberry Shake network, a distinct seismic signature has emerged. One particular station, designated R25B3, has detected a distant 5.9 magnitude earthquake from Russia, highlighting its sensitivity. Within Santorini's vicinity, the latest recorded earthquake measures approximately 2.5 in magnitude, with multiple quakes in the range of magnitude 2 and 3 scattered throughout the region. While individually these may seem minor, their pattern raises concerns. A review of the last 24 hours of seismic data in Santorini unveils an intriguing phenomenon. Strong tremors, marked in red and blue on the seismograph, are evident. However, an even more significant observation lies in the continuous, low-frequency signal underlying the typical earthquake patterns. This type of signal is characteristic of magma movement, similar to what has been observed at other volcanic hotspots such as Kilauea and Iceland. Approximately 5 to 6 hours ago, this movement became particularly prominent, persisting for about an hour and a half before subsiding. Following this event, multiple magnitude 4 earthquakes were recorded, further suggesting that underground magma may be shifting. Recent activity also hints at a possible migration of seismicity toward the north and east, diverging from the primary swarming region. Notably, a magnitude 4.1 earthquake, followed by a magnitude 3 event and a series of smaller tremors, has been detected in this new area. While quakes remain dispersed, the presence of larger tremors in the northern sector raises the possibility that magma is seeking a new pathway beneath the surface. This emerging pattern warrants close observation. The presence of sustained seismic activity, combined with fluid movement signatures, suggests that the region may be experiencing increased volcanic unrest. Whether this will lead to further escalation remains uncertain, but the data strongly indicates that significant subterranean changes are occurring. Seismic data in the Santorini region has revealed a pattern of continuous activity not previously observed in this earthquake swarm. A distinct, thicker waveform appears on multiple seismograph stations, suggesting fluid movement beneath the surface. Following this activity, a series of larger earthquakes have been recorded, with a noticeable migration toward the north. Recent tremors continue to be scattered throughout the area, including a magnitude 2.5 event to the south and a 1.6 elsewhere. This distribution indicates an evolving seismic process that requires close monitoring. Seismologists analyzing these patterns would likely recognize the telltale signs of magma movement, as the persistent signal is not caused by external factors like wind. The United States Geological Survey, USGS, has only reported a single magnitude 4.3 earthquake in the region, but independent seismic data suggests a far more complex and widespread sequence of events. Beneath this area lies a network of rift boundaries, possibly influenced by a fragment of an ancient tectonic plate buried under the African region. This geological structure may be playing a role in the region's heightened seismic activity. While additional research is needed to confirm this connection, it raises intriguing questions about the deep structural forces at work. Elsewhere, a magnitude 5.8 earthquake, downgraded from 5.9, struck Russia, highlighting ongoing global seismic activity. In the Philippines, seismic activity remains elevated, with a mix of magnitude 2s, 3s, and a few 5s, suggesting that tectonic stresses may be building toward a larger event. The broader Pacific region, including Vanuatu and New Zealand, has also seen minor shifts, with earthquakes in the magnitude 4 and 5 range. While current activity appears shallow, ongoing surveillance is necessary to detect any potential escalation. With so many interconnected tectonic movements occurring worldwide, the situation remains dynamic. Understanding the implications of these seismic shifts requires continued monitoring, as patterns of movement beneath the Earth's surface could signal larger events on the horizon. A magnitude 4.0 earthquake was recorded at a depth of 67 kilometers, linked to the Hikurangi subduction zone just offshore. This was followed by a magnitude 3.0 event further north at a depth of 27 kilometers. While no significant seismic activity has been detected yet, the region remains an area of concern, as it is a subduction zone with the potential for a major earthquake in the future. Seismic activity across the Atlantic Ocean remains relatively quiet, with only remnants of older events from the previous night. In South America, earthquake activity has been minimal, with only a few low-magnitude tremors recorded. Along the Middle America Trench, Several magnitude 4 and 5 earthquakes have occurred, but no unusual tectonic movement has been noted. In California, seismic activity has been relatively subdued. The Malibu Coast Fault, an area previously discussed for its potential movement, registered a minor magnitude 2.0 earthquake, currently the only tremor above magnitude 2.5 in Southern California. Further north, minor seismic events have been recorded near the Clear Lake volcanic field, likely linked to ongoing geothermal activity. The Hayward Fault has shown increased activity in recent days, with a sequence of 9 recorded earthquakes, including several above magnitude 3.0. This fault is significantly overdue for a major rupture, with estimates suggesting a magnitude 6.7 or greater event is possible. If movement extends to other nearby faults, such as the Rogers Creek Fault or the Calaveras Fault Zone, the potential for an earthquake as large as magnitude 8.0 cannot be ruled out. Even a 6.7 magnitude earthquake on the Hayward Fault alone would be devastating due to the dense population centers along the East Bay, particularly in the San Francisco region. Seismic activity appears to have slightly subsided today, with only a single minor earthquake recorded along the Calaveras Fault. Meanwhile, the Clear Lake volcanic field remains active due to geothermal operations, though only small microquakes have been detected. Unfortunately, satellite imagery for this area is currently unavailable, but the region hosts dozens of geothermal plants that continue to influence seismic patterns. The Pacific Northwest has been relatively calm, with no significant events reported. At Yellowstone, no unusual seismic activity has been detected. While the region remains under close observation, current data suggests a period of relative quiet across much of the western United States. However, given the dynamic nature of Earth's tectonic systems, continuous monitoring remains essential. Yellowstone National Park recently experienced strong wind events, which have been verified as atmospheric disturbances rather than seismic activity. Since then, seismic readings in the area have remained relatively quiet. Some anomalous signals appear intermittently on certain seismograph stations, but these do not register on surrounding instruments, indicating they are likely due to external interference rather than genuine earthquake activity. Meanwhile, the Texas oil fields have seen increased seismicity, a well-documented consequence of deep injection wells and hydraulic fracturing in the region. In contrast, much of the eastern United States remains seismically inactive, with no significant events reported. Hawaii continues to experience minor seismic activity, with small magnitude earthquakes occurring both on land and offshore. A notable magnitude 3.8 earthquake was recorded near the formerly named Loihi Seamount, now officially known as Kamaehuakanaloa. While not unusual for this volcanically active area, the ongoing seismic activity suggests continued geological movement beneath the ocean floor. Seismic activity along the Pacific Ring of Fire remains dynamic. The northern portion of the ring continues to show tectonic stress, with minor to moderate earthquakes occurring in the region. California, after a period of heightened activity, has seen a temporary lull. However, in the Santorini region of Greece, seismic patterns suggest the movement of underground fluids, a phenomenon that can sometimes precede volcanic or hydrothermal activity. This area has seen increased seismicity in recent weeks, making it an important zone for continued monitoring. In space weather, solar activity remains relatively mild. The Sun is currently experiencing unsettled conditions at higher latitudes due to a high-speed solar wind stream originating from coronal hole 14, now positioned toward the western limb. Despite this, no significant geomagnetic storms are expected. Sunspot activity remains weak, with no major flaring anticipated in the near future. While one sunspot shows slight complexity, it lacks the magnetic structure necessary for significant solar eruptions. Stay tuned for updates as more information unfolds, and be sure to subscribe for the latest seismic events happening around the world. If you found this video informative, don't forget to like and share. Stay safe, stay aware, and I'll see you in the next one.